Hi students, this video is on magnetic effect of electric current part 3. In this video now let us discuss the three important points, that is the magnetic field due to a current carrying a straight conductor, and the second one due to a circular loop or coil, and third one due to a solenoid. Now let us discuss the first one, the magnetic field due to a current carrying a straight conductor. So as we have studied the magnetic effect of electric current, when current is passed through a conductor, the magnetic field is produced around it. Now this magnetic field can be traced by means of iron pilings or a small compass needle, as we have done it in the case of bar magnet. Now to find the pattern of magnetic field in case of a straight conductor, now let us study one experiment here. Uh, For this, take a thick straight conductor and pass it through the center O of a thick cardboard. Now connect the two ends of the conductor to the terminals of a battery through a rheostat, ammeter and a plug key as shown in the figure. Now as so that the current flows through a conductor. Then sprinkle or spread some pieces of iron pilings on the cardboard. These arrange themselves in a concentric circles around O as shown in the figure. When the cardboard is trapped gently, these concentric circles represents the magnetic field lines. This shows that there exists a magnetic field around the straight conductor carrying a current, and it is in the form of concentric circles. So these circles represents the magnetic field lines with the conductor is at the center. Now from this experiment we can conclude that the current carrying a straight wire produces the magnetic field around it, and these magnetic field lines are in the form of concentric circles with conductor is at the center. Now in order to find the direction of magnetic field, how to find the direction of magnetic field here, that is also an important point. Now let us see how to find the direction of magnetic field produced in a conductor carrying a current. So there is a one rule to find the direction of the magnetic field, that is called as the right hand thumb rule. So this rule is used to find the direction of magnetic field. Now imagine the right. Now imagine the what? Um, Now imagine the straight conductor in your right hand such that the thumb points in the direction of the current, and the direction of the curling of the fingers of the right hand gives you what? The direction of the magnetic field lines. So when you hold the conductor in such a way that thumb gives the direction of the current and the curled fingers gives the direction of the magnetic field lines. And also if you change the direction of the current and if you change the direction of the current, the direction of the magnetic field lines also changes here. So in this case, as you are seeing here, the direction of the magnetic field is in the clockwise direction, and here when the direction of the current is changed, the direction of the magnetic field line here is in the anti-clockwise direction. So when you change the direction of the current, the direction of the magnetic field lines also changes here. So now the next point, what is the pattern of magnetic field due to a circular loop carrying a current? Soon after Oersted discovery of magnetic effect of a straight current carrying a current, Ampere found that the loop of wire also had a magnetic field. In order to find the magnetic field due to a coil, it is held in a vertical plane and it is made to pass through a smooth cardboard in such a way that the center O of the coil lies at the cardboard. A current is passed through the coil and iron pilings are sprinkled on the cardboard. These are pilings arrange themselves in a pattern similar to the as shown in the figure. This represents the nature of magnetic field lines. And the magnetic field lines near the coil are nearly circular and concentric. The direction of the field lines can also be found by applying the right hand thumb rule. And near the center of the coil, the field lines are nearly straight and parallel. The direction of the magnetic field at the center is perpendicular to the plane of the coil. These are the some important point related to this, and how you can increase the strength of the magnetic field at the center of a circular coil carrying a current. So you can increase the strength of the magnetic field by increasing the current flowing through the coil, and also by increasing the number of turns used in the coil, and also by decreasing the radius of the coil. So in these ways you can increase the magnetic field strength. So this is the points, these are the some important points related to the what, the magnetic field due to a current carrying a circular coil. So now let us discuss the next point about the solenoid. So now what is a solenoid? An insulated copper wire wound on a cylindrical cardboard cardboard or a plastic tube such that its length is greater than its diameter is called as a solenoid. Or simply, an insulated copper wire wound in the form of a cylinder is called as a solenoid, as shown in the figure. Now a current carrying a solenoid behaves as a bar magnet. This is also an important point. That is, the magnetic field lines are exactly identical to those due to a cylindrical bar magnet, with one end of the solenoid acting as a south pole and its other end is a north pole. Thus, a current carrying a solenoid behaves like a bar magnet with fixed polarities at its ends, so that therefore the solenoid is uh, called as a what, it behaves as a what, a bar magnet. That means what, the magnetic field lines are similar to the what, the bar magnet. Now a very important point on what factors the strength of the magnetic field is depends here. Now the magnitude of the magnetic field in case of a solenoid is directly proportional to what, current flowing through a solenoid. That means what, as current flowing through a solenoid increases, the strength of the magnetic field is also increases, and also the magnitude of magnetic field is directly proportional to the number of turns used in per unit length of the solenoid. That means as the number of turns increases, the strength of the magnetic field produced due to solenoid also increases. So these are the some important points related to the what, the solenoid. So therefore till now we have discussed three important points in this video, that is the magnetic field due to a current carrying a straight conductor, and current through a circular loop or coil, and third one, solenoid.